Hello, is my screen visible? Okay. Wait. What is okay? Okay. So today I'll be talking about this random forest, which is a special case of bagging ensemble technique. So from the name itself, we can understand a little bit about the working logic of random forest. Word random means because we are randomly selecting a subset of the whole data set and trying to get the prediction. Okay, so forest means group or collection of trees. Basically, this the it is a collection of decision trees. Okay, the base algorithm in a random forest is decision trees. Okay, so let's go and understand about the whole logic of this random forest. In random forest, what it is based on bootstrapped aggregation. Bootstrapped means you are trying to collect a subset of the whole data set and trying to give the subset of this whole data set to a collection of base models, which are basically decision trees. Okay, so there is a method of sampling here. It is of two types. Number one is row wise sampling. Second is column wise sampling. Suppose you have got a data set. There are thousand rows, and you have to in row wise sampling you have to collect a subset of suppose 500 rows. Okay, so randomly you will be selecting 500 rows and give it to the first estimator or the first decision tree. Okay, then what will happen? You will put it back. You will put it back, and again you will be selecting 500 random rows and give it to the second decision tree. Likewise, suppose you have taken 100 decision trees. So for 100 decision trees, you will be trying to take 100 number of subsets from rows, 1000 the whole data set, and you will give to the decision trees. Similarly, in case of column wise sampling, suppose there are 10 number of rows, you will be selecting, like if you say five number of columns. Randomly, you will select five columns for every different decision tree. Okay, then then okay, there is another concept, that is with replacement and without replacement. With replacement, what happens is the same thing that I told you. You are selecting 500 rows and you are putting it back into the data set. That is with replacement. You are replacing it. But when you are choosing without replacement, there is no situation of duplicacy, because when you are replacing it and you are randomly selecting 500 rows from 1000 rows, it may happen that one row is selected for 2 3 times. It can happen, but when you are choosing it to be without replacement, so there is no chance of uh, duplicate rows. Okay, then then what happens is, suppose we are having 100 decision trees. Out of 100 decision trees, suppose 70 number of decision tree give the prediction that the prediction is 1. From out of 1 and 0, the prediction is 1, and the remaining 30 decision trees give the prediction that the prediction is 0. So since 70 is greater than 30, so we will take the majority voting count, and the final prediction you will get as 70. Okay, the in case of this was in case of classification problem. In case of regression problem, 100 decision trees will give you 100 outputs, 100 numbers. So we will what it will do, it will try to take out the average. It will try to calculate the mean, and that mean value will be the output or the final prediction of the random forest. Okay, this is the basic working logic of random forest. Okay, so next, Uh, so why we are using a random forest and why it works so well? Okay, because uh, whenever we are trying to create a model or algorithm, our basic objective is to create a model which is and low biased and sorry, low biased and low variance. Okay, so uh, a lot of times what we face is, suppose for example decision tree. What it does is it creates many a times it creates a overfitted model. It tends to be a low bias but high variance. Okay, so so you see, this is to explain it better. I have attached a picture here. This is a collection of 500 points. There are two classes. One is purple, one is yellow. Okay, so these lines or these regions you can see. This is the classification decision boundaries. Okay, this yellow strip is for yellow dots, and this purple region are for the purple dots. Okay, so if you focus here, you will see this whole strip is a yellow strip, but only one yellow dot is present here. Okay, so another place if you see this region, this strip is also the same thing is happening. Only one dot is here, and other than that, there is no other yellow dots. There are blue dots, but still, it is showing this to be a yellow strip. Means that you can directly see that this is an example of a overfitted model. Okay, it is showing extra yellow region. Okay, because but still it is unnecessary, but still it is showing. Okay, and here the same data set, here random forest algorithm is applied, and you can see unnecessary yellow strip are decreased now. It is showing a very well optimized result. It is giving you, it is uh, giving, now it is giving very balanced training error and testing error. Of course, the training error has little bit increased, but it is very well optimized now. It is working. It will give you a very better prediction than decision tree. Okay, you can see here only the region, the for yellow strip is restricted around this yellow dots only. This one. Okay, so this is the very huge benefit of random forest. So one question may be coming into your mind, then what is the difference between this random forest and bagging? Both of them are like working logic is similar. So still there is a very important difference between both of them. First thing is, in bagging you can use different algorithms uh, as the base models. But in the random forest, the decision tree will be the only base model. Okay, in bagging you can use KNN, SVM, decision tree, anything. You can use a collection of different algorithms. Okay, that is the one difference. But second very important difference is, like I told you, there is a column-wise sampling. Okay, column sampling or feature sampling method. In bagging, what happens is there is a tree level feature sampling. Then now what is this tree level feature sampling? Suppose out of five features in a data set, you are setting uh, two features to be used for the tree making. Okay, so in bagging, what will happen is from the parent node to the last leaf node, you will see only the whole tree is made up using these two features only. These two features only that you have selected in case of bagging. But in case of random forest, uh, from if you want to use two features of out of five features to create the whole decision tree, uh, from the parent node will use, suppose out of five it will use first feature and third feature. It will create two nodes, suppose two nodes, left node and right node. Again, again for the left node, again from five, it will select another, randomly select another two features. For again for the right node, again from out of five, 2 nodes will be selected for the feature sampling. So you can see that there is an extra randomness. Okay, so this extra randomness is helping us to create a very better, well optimized model. Okay, this is a very useful and very important point about this difference of random forest and bagging. Then how we can use the hyperparameters of this random forest, and which are very important random hyperparameters of this random forest. N estimators. It means that the how many number of decision trees you want to be there in your random forest. 100, 200, or 300. Uh, how many number of decision trees you can take. Max features. The I told you the column sampling, feature sampling. How many number of features you want want for tree making. Okay. Bootstrapping means the bootstrapping aggregation means the sampling. If you select it to be true, then it will be randomly selected. Or if you set it false, there will be no sampling. Okay, it will take the whole data set. Max sample means how many number of rows you want to give your each estimator. Okay, from suppose out of 15,000 you are taking 1,000, or you can give it in percentage also, 50%, 30%, or 80%, and likewise. So this was it about this random forest. If you have any doubts, you can unmute yourself and ask me question if you have any doubts.
No doubts, bro.
Okay, I'm ending the meeting.